So this process involves heat flow because the water is at two different temperatures. So we have T high at 100 degrees Celsius and T cold at 0 degrees Celsius. So a final T equilibrium, if you want, is going to be about 50 degrees Celsius. And although the processes are irreversible, we can calculate the entropy for the initial and hot and cold waters as separate processes and then add the two together. The change in entropy for the high system is going to be given by MC delta T over T, right? That's the Q over T that we know. And if we take small changes of temperature at a time, we can rewrite this as MC dt over T. So we can find the integral to find the total entropy change. I should have put a D over here. To find the total, we can integrate, and this will be MC integral of dt over T. Right? We can take the MC out because they're constants with respect to time. And then we have the 2 degrees. For the high temperature, though, we got to keep in mind that it started at, this is going to be natural log of T2 over T1, right? And we know that for the high temperature, since we're calculating the change of entropy of the high level, it's going to be the mass, which is 1 kilogram, times 4190 joules per kilogram Kelvin. And then natural log of the high temperature starts at 100, which is 373.15 Kelvin, and goes to 50, which is 323.15 Kelvin. And that will give us minus 603 joules per Kelvin. And then similarly, we can say that the change in entropy for the cold is going to be ms natural log, mc natural log of T2 over T1, but now for the cold system. This is for the hot system. So this is going to be, again, mass of 1 kilogram, 4190 joule per mole Kelvin, times the natural log of the initial heat, or the final heat for the cold system is 50, so that's 323.15 Kelvin, but the initial temperature was 0, so that's 273.15 Kelvin. And if we do that, we get a positive 705 joules per Kelvin change in entropy. So the change in entropy for the system then is going to be the sum of the 2 entropy changes. And we get minus 603 joule per Kelvin plus 705 joule per Kelvin, which is 102 joules per Kelvin.